All right, welcome back to Algebra. Well, to finish the year, we're going to look at two more ideas, two more topics that will help us in our process of solving for the missing pieces of a triangle. So far, what we've done for the first part of this section is we've talked about beginning with a right triangle, so a triangle that has a 90-degree angle, and then either given two sides and that 90-degree angle, or two angles and one side. Remember, the idea was as long as you know half the parts of a triangle and at least one of those is a side, like here is one side, here's actually two sides, but as long as at least one of those is a side, then you should be able to find the missing pieces. And what we've looked at so far is how to find the missing pieces of a triangle using sine, cosine, and tangent, using the definitions opposite, hypotenuse, adjacent, and so on. Okay? And so the key has been that because we've had a right triangle in every single one of our problems, we've always had a hypotenuse. But unfortunately, not every situation in real life will be representable with a right triangle. Other times we have situations where we're going to have different types of triangles. So we're going to have two other tools that we're going to use to help us find the missing pieces of a triangle when we do not have a right triangle. And the first one that we're going to look at in this section is called the law of sines. All right, this one's called the law of sines. And what we do is we create three equal fractions where we put the sides of the triangles across the numerators in the three fractions, and then we put the sines of the angles across the denominators. And notice how they're paired up. Side A gets paired up with angle A, side B gets paired up with angle B, side C gets paired up with angle C. So sides and their angles are always paired up. So A over the sine of A, B over the sine of B, C over the sine of C. Okay? And then what we're going to do is we're going to, once we have these fractions set up, pretend my hand symbol here is a little bit bigger. But what we're going to do is we're going to disregard one of the fractions. So what I'm trying to do with my little hand icon there is have you disregard the first fraction. So what you'd be left with then is two equal fractions. And when you have two equal fractions, you guys know how to solve those. We've done that a handful of times this year. All right, what we do is cross multiply. But there's one important thing that we have to note when you put law of sines into your notebook. We can use law of sines anytime we know a pair. Anytime we know a pair, we're able to use law of sines. And by a pair, what we mean is we have to know a side and the angle opposite. We have to know a pair for law of sines to work. If we don't know a pair, then we're going to have to use our next tool, which we'll take care of in the next couple of days. Okay? But when you do know a pair, then you can use law of sines. So make sure you pause the video and get law of sines down along with the phrase, know a pair. Okay? And then once you have that in your notebook, move on to the examples. All right, so here's the first example. All right, and what we're given in this problem is a triangle with two angles, 64-degree angle, 32-degree angle, and one side being 15. All right? Now we know 3 out of the 6 parts, we know 2 angles and a side, but we do not have a 90-degree angle. We do not have a 90-degree angle. So we can't use opposite, adjacent, hypotenuse definitions. Instead, what we have to use is law of sines. Now someone might say, you can't use law of sines because you don't know a pair. And at first, you're correct. I know this angle, but I do not know the side across. I know this angle, but not the sine across. I know this side, but not the angle across. So at least to start with, you're correct, we don't know a side. But we can find a pair very easily because I tell you 2 out of the 3 angles. If we start at 180 degrees and subtract away the 2 that we know, subtract away the 64-degree angle B and the 32-degree angle C, what's got to be left over then is angle A. And so if I do that subtraction for everybody, 180 minus 64 minus 32, what we get as a result is 84. And by filling 84 into my picture, now I know an angle and a side directly across, so I now know a pair. And once I know a pair, now I'm going to be able to use law of sines. And here's how you set it up. You start yourself off with 3 equal fractions. Across the numerators, you write down all of the sides in any order you want, but I usually just go alphabetical. So side A, side B, side C. And then across the denominators, you write down the signs of the angles. All right, so I'm just going to get you started with the signs written down. And then what we do is attach each angle. Across from the 15, what angle, or let me ask it as a question. What angle is across from 15? 84. What angle is across from B? 64. And what angle is across from C? 32. Okay? And now what we're going to do is we can't work with all 3 fractions at the same time. We have to cover one up. All right? And to cover up one of the fractions, what I'm going to do is pretend to cover up the third one. So I'm just going to maybe choose a different color so it doesn't block it out too much. But I'll use green and pretend to cover up the third fraction. Now if I cover up the third fraction, what I'm left with is 2 equal fractions. And I know how to solve those fellas. I cross multiply. So I'd multiply B times the sine of 84 degrees. And I'd multiply 15 times the sine of 64 degrees. Now I just need to use my calculator, right? Just need to use my calculator to find the sine of 84, which is 0.99. The sine of 64, which is 0.90. And then to solve for b, I just have to divide both sides by 0.99. So little b, that's a terrible b, let me try that again. That one looks a little better. So little b then, guys, is going to be 15 times 0.9 divided by 0.99. And what we get is, let's see, there we go, is about 13.6. So we have side B, 13.6. And then to find side C, we just need to cover up a different fraction. So how about if I change to yellow, just so you guys can see the difference. And then what I might do is cover up the fraction that's in the middle and cross multiply with the other 2. Cross multiplying this direction, I'd have little c times the sine of 84. And cross multiplying this direction, I'd have 15 times the sine of 32. Again, I've got a couple of sine values that I need to punch out with my calculator. The sine of 0.84, oops, I think I said that wrong. The sine of 84 is 0.99, and the sine of 32 is 0.53. So to solve for little c, we divide both sides by 0.99 so that those 9s cancel on the left-hand side. And then on the right-hand side, we have 15 times 0.53 divided by 0.99. And if I punched OK, I got just a hair over 8. I'm just going to call it 8.0 so that you know I rounded it to the nearest tenth. Okay, so what we found were the 3 missing pieces: the missing angle, the first missing side, and then the second missing side. So we have all 3 missing pieces. Okay, and we were able to use law of sines because we were able to figure out a pair. All right, let's try, excuse me, let's try another one of those. This time I'm starting off with an obtuse triangle, but the idea is going to be the same. Find the missing pieces. Okay? And this time I made it a little bit easier on you. Even though I gave you two angles again right off the bat, I gave you two angles right off the bat, meaning you could find the third angle by starting at 180 and subtracting away the two that you know. So if I subtract away the 142 and I subtract away the 11, what's left over has to be the third angle. So if I start at 180 and subtract away 142 and 11, what I'm left with is 27. So I can fill 27 into my picture right off the bat. Okay? And then because I know a pair right off the bat, this time I made it a little bit easier on you guys. I showed you a pair right away. 142 degrees and 38. Those are a pair because they're directly across from each other. And anytime we know a pair, we can use law of sines. So what we'll do is we'll put down the three sides in the numerators. In fact, let me put the arrow there and say, remind you, sides across the top. Again, I usually go alphabetical, it doesn't really matter. But side A, side B, side C. And then downstairs, down in the denominators, are the signs of the angles. Okay? So across from little a is 11 degrees. Across from 38 is 142 degrees. And across from little c is 27 degrees. Okay? And again, all you have to do is cover up one of the fractions at a time and cross multiply. As an example, if I cross multiply with the two fractions to the left, I'd have little a times the sine of 142 is equal to 38 times the sine of 11. Two trig values that I can punch out using my calculator. The sine of 142 is 0.62, and the sine of 11 is 0.19. So to solve for little a, divide both sides by 0.62. So that little a is approximately 38 times 0.19 divided by 0.62, and we get approximately 11.6. Right? And then to solve for little c, I could use the two fractions to the right. In other words, cross out the first fraction and cross multiply with these two. So I could have little c times the sine of 142 and 38 times the sine of 27. Again, two trig values that you need to punch out on your calculators. The sine of 142 is 0.62 and the sine of 27 is 0.45. All right, so to solve, we want to get rid of that 0.62, so we divide. So little c then would be equal to 38 times 0.45 divided by 0.62. And we ended up at about 27.6 or so. So again, we were given three parts of the triangle, and we were able to find the other three: the missing angle, missing side, and missing side. All right, looking okay with everybody? Right? I hope so. I hope everybody's doing okay there. All right? And then to finish off this section, we're just going to look, this is much easier, that first thing, law of sines, is much more difficult. But to finish off, we're just going to look at another way to calculate the area of a triangle. Okay? Now, area, we've been talking about since late elementary school. And since late elementary school, you've had I forgot to hit my pencil there, guys. Here we go. We've had a formula for the area of a triangle since elementary school, late elementary school, that looked like this. Area of a triangle is equal to 1/2 times the base times the height. All right? There was a condition on this. To use this formula, the base and the height of the triangle had to be perpendicular to each other. Well, today I'm going to give you another formula for the area of a triangle. Okay? All right, and that formula is a formula that we can use anytime we're in a situation where we have what's called SAS. Now, the S's stand for sides, the A stands for angle. And we purposely put the A in the middle, in between the two sides. Next year in geometry class, we'll say that the angle is included between the two sides. And when we jump to the number examples that are going to follow, I'll explain better what the A in the middle actually means. But the formula I need everybody to write down is then this one. Another formula for the area of a triangle is 1/2 times little a times little b times the sine of capital C. And since these two fellas right here are lowercase letters, these represent the sides, and this is an uppercase letter, so this represents an angle. All right, so that's another way in which we can get the area of a triangle. And again, anytime we're in an SAS situation, we can use that formula. So let me show you how that works in examples. Feel free to pause the video to make sure you get that in your notebook. But then once you're done with that, move on to the examples. Okay, the first example, I give you two sides and an angle of this triangle, but what I need you to notice is that where we have the angle, we know the two sides that make up that same angle. All right, we don't need to know anything about this side over here. As long as we know two sides and what's called the included angle, or if you'd rather, the angle in between, you guys can calculate the area. So the area of this triangle then is going to be 1/2 times the first side times the second side multiplied by the sine of the angle in between. So again, please notice these first two are sides, and then this number is the angle in between. And it just simply becomes a calculator problem, which usually don't turn out very even, Steven, so we usually give these to you as decimals. So it'd be 1/2 times 9 times 12 times the sine of 38. And when we punch that out, we get an area then of approximately 33.2 square units. All right? And let me just jog through one more example, just so you have two for your notebook potentially. Okay, here's another triangle. Again, I'm telling you two sides and the angle in between. All right, again, please notice where the angle is, and then I tell you the two sides that make up the angle. So the area then of that triangle is going to be 1/2 times the first side times the second side multiplied by the sine of the angle in between. All right, and when we punch out the math again, usually these are kind of ugly decimals because of the trig function, which usually doesn't turn out very nice and even, Stephen. Approximately, this time we get 45.2 square units. Okay? Alrighty, so that's law of sines and the formula for calculating area in a different way than you've seen before going back to elementary school. So feel free to stop this video, have a little bit of a break, and then go ahead and get started on the assignment problems for 13.5. Okay? Have a great day. Talk to you soon.